Bonding the Whirlpool top motor case to the cold water pipe is essential for safety. The purpose of this bond is to provide a low resistance path for any electrical current that may leak from the motor. This bonding helps ensure that the metal case of the motor does not become energized, which could create a shock hazard for users. The Whirlpool bathtub is primarily made of non-conductive materials, such as plastic, which prevents electrical current from flowing easily. However, the motor of the Whirlpool tub is made of metal, which can conduct electricity. In case of any electrical fault in the motor, current can leak through the motor housing and into the surrounding environment. Bonding the motor case to the cold water pipe provides a direct path for this current to flow back to ground instead of through the water or other parts of the tub. The cold water pipe is typically connected to a copper or galvanized steel pipe that is buried underground. These pipes have a low electrical resistance and are considered a good ground reference. Bonding the motor case to the cold water pipe ensures that any leaking current is safely discharged into the ground. In addition to bonding, a ground fault circuit interrupter, or GFCI, should also be installed on the electrical circuit that powers the Whirlpool tub. A GFCI detects any imbalances in electrical current between the hot and neutral wires and automatically shuts off the power to prevent electrical shock. Periodically inspect the bonding connection to ensure that it is secure and free of corrosion. Ensuring a secure connection is crucial for maintaining the effectiveness of the bonding. Corrosion can increase the resistance of the connection, diminishing its ability to provide a low resistance path for fault currents. You should use appropriate connectors and ensure they are properly tightened. The bonding conductor itself should be of adequate size. Typically a number 8 American wire gauge copper conductor is sufficient, but always consult local electrical codes for specific requirements. The connection point on the motor housing should be clean and free of paint or other coatings to ensure good electrical contact. Similarly, the connection point on the cold water pipe should be clean to bare metal and protected from corrosion after the connection is made. When connecting to the cold water pipe, it is important to clamp securely to the metal pipe itself and not to any fittings or valves that might interrupt the electrical path. The grounding system of a building is designed to provide a safe path for fault currents to return to the source, tripping the circuit breaker and energizing the circuit. The grounding electrode system, which typically includes the cold water pipe, ground rods, or concrete encased electrodes, provides a connection to the earth, helping to stabilize the electrical potential of the system. It is important to understand the difference between grounding and bonding. Grounding connects the electrical system to the earth, while bonding connects various metal parts within the electrical system to ensure they are at the same electrical potential. This equipotential bonding minimizes the risk of electrical shock by reducing the voltage differences between different metal parts that a person might come into contact with. In the context of the Whirlpool tub, the bonding of the motor case to the cold water pipe ensures that if a fault occurs, the motor case and the cold water pipe will be at approximately the same voltage, reducing the risk of current flowing through a person who touches both. It is also important to note that while the cold water pipe is commonly used as a grounding electrode, it is not always the primary grounding electrode. Modern electrical codes often require additional grounding electrodes such as ground rods or concrete encased electrodes to supplement the cold water pipe. The effectiveness of the grounding system depends on the quality of the connections and the resistance of the soil. In areas with high soil resistivity, additional grounding electrodes may be required to achieve an acceptable grounding resistance. Regular inspection and maintenance of the grounding system are essential for ensuring its continued effectiveness. This includes checking the condition of the grounding electrodes, the tightness of the connections, and the absence of corrosion. If the cold water pipe is used as a grounding electrode, it is important to ensure that it is electrically continuous and that there are no insulating fittings or couplings that might interrupt the electrical path. Plastic pipes, for example, will interrupt the electrical path and prevent the grounding system from functioning properly. In such cases, a bonding jumper should be installed around the plastic pipe to maintain electrical continuity. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. The GFCI should be installed in a readily accessible location, such as a bathroom or near the Whirlpool tub. It is also important to test the GFCI regularly to ensure that it is functioning properly. Most GFCIs have a test button that can be used to simulate a ground fault and verify that the device trips. The GFCI should be tested at least once a month and more frequently if it is located in a damp or wet environment. If the GFCI fails to trip when tested, it should be replaced immediately. GFCIs are designed to protect against ground faults, which are electrical faults that occur when current flows to ground through an unintended path. Ground faults can occur when the insulation on a wire is damaged, allowing current to leak to ground. They can also occur when a person comes into contact with a live wire and ground. GFCIs work by monitoring the current flowing in the hot and neutral wires. If there is a difference in current between the two wires, it indicates that some current is flowing to ground. When the GFCI detects a ground fault, it quickly shuts off the power to the circuit, preventing electrical shock. The tripping time of a GFCI is typically very fast, on the order of milliseconds, which is fast enough to prevent serious injury. GFCIs are required in many locations, including bathrooms, kitchens, garages, and outdoor areas. They are particularly important in areas where there is water, as water can greatly increase the risk of electrical shock. In addition to bonding and GFCI protection, it is also important to follow all other applicable electrical codes and safety standards when installing a Whirlpool tub. This includes using properly sized wiring, installing the tub according to the manufacturer's instructions, and ensuring that all electrical connections are made correctly. It is also important to have the installation inspected by a qualified electrical inspector to ensure that it meets all applicable requirements. When working with electricity, it is always important to exercise caution and to follow all safety precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. Be aware of the location of overhead power lines and avoid contact with them. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Maintaining the electrical safety of a Whirlpool tub involves regular inspections and testing. Check the condition of the wiring, the tightness of the connections, and the functionality of the GFCI. Look for any signs of damage or corrosion, and replace any components that are worn or damaged. Test the GFCI regularly to ensure that it is tripping properly. If you notice any problems, such as flickering lights or a burning smell, turn off the power to the circuit and call a qualified electrician. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical equipment, including Whirlpool tubs. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC covers topics such as wiring methods, grounding, bonding, overcurrent protection, and GFCI protection. It also includes specific requirements for different types of equipment and locations. When installing a Whirlpool tub, it is important to follow the NEC requirements to ensure that the installation is safe and compliant. Local electrical codes may also have additional requirements that must be met. It is important to check with the local authorities to determine the applicable codes and standards. Electrical inspections are typically required for new electrical installations and for major renovations. The purpose of the inspection is to verify that the installation meets the applicable codes and standards and that it is safe. The inspector will check the wiring, grounding, bonding, overcurrent protection, and GFCI protection. They will also check the installation of the equipment to ensure that it is done properly. If the installation fails the inspection, the inspector will provide a list of deficiencies that must be corrected before the installation can be approved. Correcting the deficiencies and having the installation re-inspected is essential for ensuring the safety and compliance of the electrical system. In summary, bonding the Whirlpool tub motor case to the cold water pipe is a critical safety measure that helps prevent electrical shock. This bonding, combined with GFCI protection and regular maintenance, ensures a safe and enjoyable experience. Always follow applicable electrical codes and safety standards, and consult a qualified electrician if you have any questions or concerns. The bonding conductor should be connected to the motor housing using a listed connector suitable for the purpose. The connector should be installed in accordance with the manufacturer's instructions and should provide a secure and reliable electrical connection. The bonding conductor should be routed in a manner that protects it from physical damage. It should be supported and secured to prevent it from becoming loose or disconnected. The bonding conductor should not be spliced or otherwise interrupted between the motor housing and the cold water pipe. Any splices or connections should be made in accordance with the NEC requirements. The cold water pipe should be electrically continuous from the point of connection to the grounding electrode system. Any insulating fittings or couplings in the cold water pipe should be bypassed with a bonding jumper. The bonding jumper should be sized in accordance with the NEC requirements. The cold water pipe should be made of metal such as copper or galvanized steel. Plastic pipes are not suitable for use as a grounding electrode. The cold water pipe should be in direct contact with the earth for at least 10 feet. This can be achieved by burying the pipe underground or by connecting it to a grounding electrode that is buried underground. The grounding electrode should be installed in accordance with the NEC requirements. The grounding electrode should be made of metal such as copper or galvanized steel. It should be at least 8 feet long and should be buried at least 8 feet deep. The grounding electrode should be connected to the grounding electrode system with a grounding electrode conductor. The grounding electrode conductor should be sized in accordance with the NEC requirements. The grounding electrode conductor should be routed in a manner that protects it from physical damage. It should be supported and secured to prevent it from becoming loose or disconnected. The grounding electrode conductor should not be spliced or otherwise interrupted between the grounding electrode and the grounding electrode system. Any splices or connections should be made in accordance with the NEC requirements. The grounding electrode system should be connected to the service equipment with a main bonding jumper. The main bonding jumper should be sized in accordance with the NEC requirements. The main bonding jumper should be routed in a manner that protects it from physical damage. It should be supported and secured to prevent it from becoming loose or disconnected. The main bonding jumper should not be spliced or otherwise interrupted between the service equipment and the grounding electrode system. Any splices or connections should be made in accordance with the NEC requirements. The service equipment should be grounded to the grounding electrode system in accordance with the NEC requirements. The grounding of the service equipment is essential for providing a safe path for fault currents to return to the source. The grounding of the service equipment helps to protect against electrical shock and fire hazards. The grounding of the service equipment also helps to improve the performance of the electrical system. When installing a Whirlpool tub, it is important to follow all of these requirements to ensure that the installation is safe and compliant. Failure to follow these requirements can result in electrical shock, fire hazards, and other safety problems. It is always best to consult a qualified electrician for assistance with electrical installations. A qualified electrician has the knowledge and experience to ensure that the installation is done correctly and safely. A qualified electrician can also help you to comply with all applicable electrical codes and standards. Remember to consult your local electrical codes and a qualified electrician for specific requirements in your area. The NEC is a comprehensive document, and it is important to understand all of the requirements before beginning any electrical work.